Hello, I'm Channa Bankapur. I'm going to discuss my solution to the LeetCode problems, range sum of BST and remove interval. Both of these are today's daily challenge problems on LeetCode. I'm going to solve both of them. The first one is range sum of BST. So we have a BST given, binary search tree, and a range starting from low to high, both inclusive. So suppose if the range is from 5 to 15, then this is going to be the low point and this is going to be the high point. So there are four nodes which fall into the range and we need to find the sum of them. In this case, it's going to be 5 plus 7 plus 10 plus 15, which is 37, right? So that's what we need to find. And so how do we solve this one? um, we can just go recursively on every node, and if it falls in the range we can add that, but that is going to take, we need, in that case we're going to go visit every node. We don't have to if a whole subtree doesn't fall in the range. So that's how we are going to make it a little more efficient, right? So what we're going to do is, if left of the range, so the range is from left to right, right? If the left of the range is lesser than roots val, then only there could be some nodes in the left subtree that fall in the range. Otherwise, there cannot be any nodes. So that's when I'm going to process roots left of the left subtree of the root, right, of the tree. So we're going to process that. Similarly, if right of the range is greater than roots value, then there could be some nodes on the right subtree which needs to be processed, right? So that's what I'm going to call left and right subtrees. So if these conditions fail, then we don't call them recursively, and that's how we are saving some time, right? And finally, if the root is in the range, right? If low is lesser than or equal to the roots val, and I is greater than or equal to roots val, in that case, root is also involved in the range, and then I'm going to add them, right? So in that case, I'm going to add. So that's what the root val thing is. So with these three values, whatever we process from the left and the right, and then the root val, depending on each of these, depending on the conditions, we can find the sum, right? So sum could be initialized to 0 in a place, and then it can we can keep adding them here and here and here, right? Which are all conditional, right? And then we're going to return the sum, right? So this is what we're going to do. So the idea is simple recursive idea. We can actually do it using even in order traversal, which is not efficient, where we need to go through every node. In this case, the time complexity of this one is going to be only the number of nodes in the range, right? Number of nodes which in the range, whatever the range is given, right? So we don't go beyond the range, and all of those subtrees can be excluded, right? That's the best we can do, because we need to add those number of elements anyway, right? That's the lower bound for this problem. Let me show you my code, which is kind of simple in this case. um, See, if root is null, I'm going to return 0, which is needed for recursive also. If if left is if low is lesser than the root val, then only I'm going to call the left side, root left, and then I pass the same low high. Actually, high can be changed to root val, but it's not going to add any more value to our functions. So that's why I'm just passing low and high. So I'm keep adding and now accumulating them in sum. Similarly, if high is greater than the root val, I'm going to add that. And finally, if low is lesser than or equal to root val and high is greater than or equal to root val, then only root val can be included in the range, right? In the sum, I'm going to return that. So kind of this is simple. Let me submit it and show it is accepting. It has accepted. All right. So I guess this is the simplest way of doing it, and this is the most efficient way also. But if there is any other way of doing it, if you have a different approach, let me know. I'm going to move on to the second problem, remove interval. So here we have a bunch of intervals which are already sorted in terms of the starting time. It can also be called ending time also, because all of these intervals are disjoint. That means these intervals, suppose there is an interval 0 to 2, and this another interval starts after 2. So it is 3 to 4, and then another one is 5 to 7. So it is sorted and they are disjoint. So it's a very clean input in that case. So what what we need to do here is they have given another range called to be removed range, and we need to remove all the ranges that fall into this, to be removed range. So all the intervals that fall into this range, and return the remaining part. So obviously, if an interval totally falls into the range, we can remove it. But what if something partially falls into that? So we need to cut that interval into a part and then return. Say for example, 0 to 2 is an interval here, but the range to be removed starts from 1. So we are going to retain 0 to 1 range and remove that part of 1 to 2 in that range. So that's what we need to take care. And we have also in this example, it ends at 6, and the last range which falls in that case is 5 to 7. So we are going to keep 6 to 7 and remove the first part. 3 to 4 is anyway gone because it is completely inside to be removed range. If there were some ranges even either before the to be removed range or after the to be removed range, they can be kept as it is. Suppose if there is a range from 10 to 20, that's going to be there in the output also, 10 to 20. So it does not have to be removed, right? So that way I'm going to do it, iteratively go over each of them and then figure out they belong to that. But it kind of falls into these stages. The first stage is I'm going to include all those the intervals that are before the to be removed range, and I'm going to keep them, right? So look at this. For I'm going to start with I equal to 0, and I just is the index for the intervals. We have this array of intervals, and if the end point of that is before the starting point of the range to be removed, they are clearly before the range to be removed, and I'm just adding them, right? This is simple case. So when I come out of that, if it is already done, I'm going to return the result, so that I don't have to check this condition in every condition here. So that's why I'm handling this case here itself. And this is a trickier case where if suppose we have a bunch of ranges here, right? So the ranges are going to start from start and end. But if the interval we want to remove is cutting one of the intervals, right? In that case, we need to retain a part of it and then discard another part of it, right? So that's what I'm doing here. If the starting point or yeah, the left edge of the range to be removed, it falls in in an interval. So the interval is from the ith interval is starting is 0 and ending is 1. So if to be removed range of 0, that means the starting point of that is inside there, right, in between them. I'm going to cut that and create a new interval which is basically first part of it, and then add it to my result. So after that, we are going to remove these bunch of intervals, or actually skip these bunch of intervals, which are totally inside the range to be removed, right? So our to be removed range. So these are the ones. It's kind of very simple. I don't have to even process anything else. I'm just skipping them. Once I'm done, again, the last case is it's just like the case we saw earlier, where so in this case, if the ending point of the range to be removed is inside an interval, then again we need to discard first part of it and then retain the second part of it. So we are doing the same thing here, right? Look at this. The ending point is to be removed of 1 is the ending point of the to be removed range. If that is inside a range, the ith interval, which is here, right? So 0 and 1. If it is inside there, then I'm going to split that range, or sorry, interval into two parts, and I'll only include the second part here, right? So after that, I move the iterator here, so that we go beyond that. So and after this, there is one more stage where all the intervals that are after the range to be removed, they are going to be simply added here. So that's again I'm doing in the last while loop in this case, right? So these are the 5 stages essentially. One is before the range here, and this is the starting of the range. This is inside of the range, and then this is ending of the range, and this is beyond the range, right? So all of them are taken care. Then I'm going to return, right? Let me show you by submitting. So it is accepting. So this works with the linear time of the number of intervals we have. So it is linear time algorithm, and if you see the constant, that should be good enough. There are 10 power 4 at the max. the number of intervals, and we work with the same amount of time, right? It can be improved a little bit by using some binary search, because it's anyway a sorted range. Um, but it's if I'm preparing a new result where I'm just copying them and pushing into the result, we cannot actually make it any better. But if I can modify the intervals itself in place, then few things can be improved, where I can directly jump to the second stage here, where we are either cutting an interval into two part, or we are already moving into this part. So that can be done, so that the first stage we don't have to go through a while loop, right? But and again, this internal part anyway has to be removed, right? So this while loop cannot be avoided in the between line number 24 to 26, right? That has to go through. And finally, when you these are some of the things we need to remove. So we need to identify a range where we need to remove. And finally, these things are kind of intact, line number 39 to 41. But the thing is, because it's a vector, we kind of have to shift to the left, and that might take again linear time, right? So that's why this is not a linked list kind of thing. In that case, probably we can improve a little bit, but here linear time cannot be improved, right? But yeah, we can improve the average case a little bit by using binary search in a couple of places, right? So that's my analysis. Let me know if you have any other take on this problem. All right. So yeah, please like the video and subscribe to the channel. Keep solving a problem every day. Thanks for watching.